Hello everyone, my name is Dipen Chhetri, BSc second sem. Today I am going to discuss about the topic Carnot's Cycle, its introduction, principle, theory and conclusion. So let's start. In 1824, Carnot designed a theoretical heat engine whose working efficiency was 100%. Heat engines are devices that can convert heat into mechanical energy, like a steam engine or motor vehicle. The working principle of all heat engines are the same, in which any working substances, gas or vapor, is brought back to the initial stage by going through different thermodynamic stages of a cyclic process. Carnot suggested that if a heat engine goes through fixed thermodynamic stages of a specified process, then the efficiency of the heat engine may be 100% possible. This is called the Carnot engine or ideal gas engine. Ideal heat engine because this engine gives maximum efficiency. No other engine can be more efficient than this. This is specified cyclic process suggested by Carnot is called Carnot cycle. Carnot एकजना साइन्टिस्ट जसले एउटा यस्तो खालको थ्योरिटिकल इन्जिन डिजाइन गर्यो जसको वर्किङ एफिसिएन्सी 100% थियो। अन्त यो हिट इन्जिन भनेको के हो भन्दाखेरि चाहिँ हिट इन्जिन चाहिँ एउटा यस्तो खालको डिभाइस हो जसले हिटलाई मेकानिकल एनर्जीमा कन्भर्ट गर्न सक्छ, जस्तै कि हिट स्टीम इन्जिन, मोटर भेहिकल एसेट्रा। एन्ड देन यो सबै हिट इन्जिनको वर्किङ प्रिन्सिपल पनि सेम हुन्छ, जसमा कुनै पनि वर्किङ सब्स्टेन्स जस्तै ग्यास या भेपरलाई एउटा साइक्लिक प्रोसेसको अलग अलग थर्मोडाइनामिक स्टेजेसबाट पठाएर फेरि आफ्नो नर्मल स्टेजमा ल्याइन्छ। कार्नोटले एउटा यस्तो सजेसन दियो कि यदि कुनै हिट इन्जिनलाई एउटा स्पेसिफाइड प्रोसेसको फिक्स्ड थर्मोडाइनामिक स्टेजेसबाट पठाउने काम गर्यो भने यो केसमा हिट इन्जिनको एफिसिएन्सी 100% पोसिबल हुन सक्छ, जसलाई कार्नोट इन्जिन या आइडियल हिट इन्जिन भनिन्छ। आइडियल यो कारण भनिन्छ किनभने इन्जिनले म्याक्सिमम एफिसिएन्सी दिन्छ। कुनै अरू इन्जिन यो भन्दा ज्यादा एफिसिएन्ट हुनै सक्दैन र कार्नोटद्वारा सजेस्ट गरिएको यो स्पेसिफाइड साइक्लिक प्रोसेसलाई नै हामी कार्नोट साइकल भन्छौं अथवा कार्नोट साइकल भनिन्छ। The Carnot engine has three main parts. First, an insulated non-conducting stand so that the transfer of energy is not possible. Second, a hot reservoir with infinite heat capacity. Heat capacity is infinite so that the temperature of the reservoir remains constant after taking any energy from it. It is also called hot source. Third, a cold reservoir. Its heat capacity is also infinite so that if any amount of heat is given, its temperature does not change. This is called heat sink. Fourth, a cylinder in which working substance can be kept. Working substance can be anything, gas or liquid. The cylinder is fitted with a movable piston. The piston and cylinder walls are made of non-conducting material, due to which transfer of heat is not possible, while the base of the cylinder is conducting. A Carnot engine goes through 4 different stages of the Carnot cycle, which is graphically displayed on PV graph. For this, first place the cylinder on the hot reservoir. Carnot engine को 3 main parts हुन्छ। फर्स्ट मा एउटा इन्सुलेटेड नन कन्डक्टिङ स्ट्यान्ड जहाँबाट इनर्जी ट्रान्सफर पोसिबल नहोस्। सेकेन्डमा एउटा हट रिजर्भियर हुज हिट क्यापेसिटी मस्ट बी इन्फाइनाइट। यसलाई इन्फाइनाइट यो कारण राखिन्छ किनभने यसले जति पनि इनर्जी लिन्छ एट द टाइम रिजर्भियरको टेम्परेचर कन्स्ट्यान्ट भइरहोस्। अन्त यसलाई हिट सोर्स पनि भनिन्छ। एन्ड देन थर्डमा एउटा कोल्ड रिजर्भियर छ जसको पनि हिट क्यापेसिटी इन्फाइनाइट हुन्छ किनभने यसलाई जति नै हिट दिए पनि द टेम्परेचर मस्ट बी कन्स्ट्यान्ट र यसलाई हिट सिङ्क भनिन्छ। फोर्थमा एउटा सिलिन्डर छ जसमा वर्किङ सब्स्टेन्सलाई राख्न सकियोस्। वर्किङ सब्स्टेन्स जे पनि हुनसक्छ, इदर लिक्विड र ग्यास। सिलिन्डरसँग एउटा मुभेबल पिस्टन लगाएको हुन्छ जसमा पिस्टन र सिलिन्डरको वाल नन कन्डक्टिङ मेटेरियलले बनेको हुन्छ, जसले गर्दा हिटको ट्रान्सफर हुँदैन। तर सिलिन्डरको बेस चाहिँ कन्डक्टिङ हुन्छ। एउटा कार्नोट इन्जिन कार्नोट साइकलको 4 स्टेजेसबाट भएर गुज्रिन्छ, जसलाई पिभी ग्राफमा डिस्प्ले गरिएको छ। यसको लागि एट फर्स्ट सिलिन्डरलाई हट रिजर्भियरमा राखिन्छ बिकज द टेम्परेचर अफ रिजर्भियर इज ग्रेटर देन द्याट अफ ग्यास। Since the temperature of the reservoir is higher than the temperature of gas, the heat flows from the heat reservoir to the gas, due to which the gas starts to expand. Since due to the heat transfer, gas is expanding, therefore the temperature of the gas remains constant. This process is called isothermal expansion. As the gas expands, the volume of the gas increases and the pressure decreases. In the next step, take off the cylinder from the hot reservoir and place it on the insulating stand. When doing so, the gas is confined to the non-conducting wall. Now let piston rise slowly upward, due to which the gas continues to expand. But this time, the gas is not getting any heat to expand. Such expansion is called adiabatic expansion. Since this expansion is taking place without heat, the temperature of the gas starts to decrease. And due to this expansion, the volume of the gas also increases and the pressure decreases. In the next step, lift the cylinder from the stand and place it on the cold reservoir. Now press the piston downward, which causes compression of the gas. The reservoir absorbs whatever extra heat is produces due to compression of the gas. In this way, the gas compresses at the same constant temperature. This process is called isothermal compression. Due to this compression, the volume of the gas decreases and the pressure is increased. In the final step, keeping the cylinder on stand again and press the piston downward. But now there is no cold reservoir to absorb the heat getting produced extra. Therefore, the temperature of the gas starts increasing. This compression is called adiabatic compression. Press the piston until the temperature of the gas rises back to equal that of the hot reservoir. This decreases the volume of the gas and increases the pressure. At the end of the step, the gas returns to its initial state. This complete cycle is called the Carnot cycle, and the engine working on it is called the Carnot engine. Now, for that reason, हाम्रो के हुन्छ भन्दा heat reservoir देखि gas को direction मा flow हुन्छ, जसले गर्दा the expansion of gas started because due to heat transfer the gas is expanding. अन्त gas को temperature बढ्नु पाउँदैन, and this process is known as isothermal expansion. Gas expand भएको कारणले gas को volume बढ्छ and then the pressure will decrease. In next step, सिलिन्डरलाई hot reservoir बाट हटाएर insulating stand मा राखिन्छ। यस्तो गर्नुले gas चारैतिरबाट non-conducting wall मा confined हुन्छ and then piston gradually pull up, जसले गर्दा gas अझै expand भइबस्छ। तर यो टाइम gas expand हुनुलाई कहीँबाट पनि heat provide भएको छैन, and this type of expansion is known as adiabatic expansion. किनभने this expansion is taking place without heat. For that reason, the temperature of gas decreases. So expansion को कारणले गर्दा gas को volume अझै बढ्छ and sidewise pressure will decrease. Next step मा सिलिन्डरलाई स्ट्यान्डबाट उठाएर cold reservoir मा राखिन्छ and then piston is pushed down, जसले गर्दा gas को compression हुन थाल्छ। compression हुँदा पनि extra heat produce हुन्छ, जुन heat reservoir ले absorb गर्छ। यसरी ग्यास त्यही कन्स्टेन्ट टेम्परेचरमा कम्प्रेस हुन्छ, जसलाई आइसोथर्मल कम्प्रेसन भनिन्छ। यो कम्प्रेसनको कारण ग्यास भोल्युम डिक्रिज हुन्छ एन्ड देन प्रेसर विल इन्क्रिज। एन्ड देन फाइनल स्टेपमा सिलिन्डरलाई फेरि इन्सुलेटिङ स्ट्यान्डमा राखिन्छ एन्ड अगेन पिस्टनलाई डाउनवर्ड प्रेस गरिन्छ। बट नाउ एक्स्ट्रा प्रड्युस हुँदै गरेको हिटलाई अब्जर्भ गर्ने देयर इज नो कोल्ड रिजर्भियर। For that reason, temperature will start to increase, which is known as adiabatic compression. फेरि पिस्टनलाई तबसम्म प्रेस गरिन्छ जबसम्म ग्यासको टेम्परेचर राइज भएर हट रिजर्भियरको बराबर आउँदैन। This result in the decrease in volume of gas and increase in pressure, and at the end gas comes to its initial stage, and this complete cycle is known as Carnot cycle. Here I disclose some calculation parts. Thank you.